So today, I want to make sure that there is no reason beyond my control that you can't get 100% on the next test, which is based on yesterday's briefing. I will let you know at the end of this week whether it's just prior to Thanksgiving break or just after Thanksgiving break. So in order to help make sure that I can go home at night and sleep and go, you know what, if somebody has a bad day on the test, I'm comfortable that I did everything I could to make sure that you knew what you needed to study. So I'm going to spend the next 40 to 50 minutes going as fast as I can to make sure that you understand what we covered in the last 5 or 6 days of lecture. So in theory, you took fantastic notes, and all you're doing right now is little check marks going, yep, I got it, yep, I got it, yep, I got it, yep, I got it. It's not my fault if you can't read your handwriting. I'm not going to lose sleep over that, Wyatt. Sorry. So, let's see who can answer this question. You want to prevent accidental engine start while you're doing an engine removal and replacement. What are those 2 steps that you could do to help prevent that? Pull the circuit breakers, and what are you going to do to the circuit breakers? You're going to zip tie them and label them. What's another thing you could do? You're probably not going to remove the battery. You're going to make sure that aircraft electrical power is off. The circuit breakers are there in case somebody comes along and turns the electrical power on. And remember, you may not be able to turn the electrical power off because it might be a big giant 747 and lots of different maintenance is getting done to it, which is another good reason to always pull the circuit breakers and zip tie them. How many L's are in auxiliary? Yeah, 1. Yay. Yeah, that's right. So APU, auxiliary power unit. I'm not going to spell it for you. Oh, darn, I put the answers up there. Sorry about that. What are the 4 uses that you could have an APU for? Let's see if I can remember. Let's see. Pneumatic power on the ground to start the engine. Electrical power on the ground to operate things on the aircraft. An in-flight emergency needing pneumatic power or electrical power. And then, running on the ground, the air conditioning power. How did I do? Did I do all right? Am I sweet? Because I have to grade it. Of course, one could also argue that if I wanted to, I could grade the text open book. Oh, just to be really clear, just in case there's any questions. During the test, all you get are your pens and pencils and your brains and your blank Scantron. Well, there'll be some fill-in stuff. There'll be plenty of that. Yes, you can use your. So, just to be really clear. And don't worry, during the test, I just walk around the room and make sure nobody's looking places they're not supposed to. That's generally what I do for 50 minutes. All right, so here's some other sample questions. What APUs idle at? What kind of engine RPM? Daniel, right? What? Say that again? 100% or full RPM, yeah? Let's see. What is an APU typical redline RPM? This is also very tough. What APUs? What are all turbine engines? Typically, the red line is really close to 100%. So same for an APU. I think that's interesting. This is an engine where the idle RPM and the redline RPM are probably right next to each other, if not the same RPM, which code comes to this next question. You got your APU up and running, and it's providing power, pneumatic power and or electrical power. What RPM is the APU running at? About 100%. Okay, it's going to be really tough. Let's see. What RPM for an APU could I ask that wouldn't be 100%? Probably, if the APU is dead, not running, and it's cold and not spinning, what RPM? I probably won't ask that question. Okay, here's another question. Compared to reciprocating engines, that's gasoline engines. There's a few diesel engines out there on airplanes, but we're talking about reciprocating airplane engines and helicopter engines. Compared to reciprocating engines, turbine engines idle at what kind of an RPM? Much higher RPMs. And I would probably say much higher percent of RPM. So here's another example question. Reciprocating aircraft engines idle at about what RPM? At about 20%, which is also, if we were doing it in regular RPMs. Well, I don't think most engines idle at 800 to 1,000. We usually put the throttle up and then make them run at 800 to 1,000. But if we pull the throttle all the way back, I would have said 400, 600. I'd have just said 500 if I was asking for one number. So 500 is what percent of 2,500? 20%. So you could fast reciprocating engines operate at idle. You'd say, well, airplanes, helicopters, they idle around 500 RPM, which is about 20% of their red line. But turbine engines, on the other hand, most of them run at 2,500 RPMs? Most turbine engines, they're all different. I've seen APUs that spin around at 40 or 60,000 RPMs, but I've seen big giant turbine engines that only spin around at 7 or 10,000 RPMs. But still, that brings up a good question. Turbine engine RPM gauges are calibrated, or they display their units in what kind of RPMs? Percents. God, I love those questions where I say this is an abbreviation for how many words? Does anybody know what QECA stands for? Quick Engine Change Assembly. How many S's are in assembly? Yeah, what are the first three letters of assembly? ASS. No, that's the first word that you could spell out of. That's the word you could spell out of the first three letters. I asked for what are the first three letters of assembly. So, what is the point? Why are there such things as quick engine change assemblies? If I was going to give you the exact answer, I'd say it reduces aircraft out of service, being out of service. Remember, let's talk about this phrase, so maybe that's another good question that you could write down. What does in service mean or out of service mean? I'm sure you're going to write that down. Amir, go ahead. Hang. You're on the right track. If the aircraft was in service, what could the airline do with that airplane? They could make money because it could fly. Very good. Yeah. All right. What's happening to the airplane, Amir? They're losing money. Why are they losing money? Well, tell me about out of service. What does out of service mean? In service means it's flying. Then out of service means it's on the ground and it's not flying. Okay, so if we said, what's the purpose of having a quick engine change assembly, what would be one way to say that answer if we used the word in service or out of service? That's not enough specifics. No. Pardon me? Answering this question, you use either the words in service or out of service. So here's the question. What is the quick change assembly? Maximize in-service time. You could also say it the other way around. Minimize out-of-service time. You got a quick engine change assembly sitting in the corner of your hangar. If you haven't answered a question yet, this is your chance. What's installed on that quick engine change? The engine, okay. Just the engine? Do you want to answer this question by listing off 27 different things? Okay, you want to answer this question easily, right? Because that way you can memorize the answer really easily. Everything that's bolted to the engine. Everything that's bolted to the engine. Based on, just for fun though, I'm trying to stand on one foot. Just so I don't dwell on one question too long. Based on the videos we saw, what was that one component that was not on the QECA? The inlet. But I would be very happy on the test if I asked the question and you said everything bolted to the engine, or you said everything attached to the engine? Got crazy and said generally everything attached to the engine, but maybe not the intake, because I saw that in a video. I would accept that, but you wouldn't. I'm not expecting you. I would accept almost everything as well. The whole point is of a QECA is so you can take the engine off, another one on as fast as you can do it safely and carefully, and you can save time by not having to pull starter off of one and stick it on the other, or a generator off of one and stick it on the other, or a hydraulic pump and stick it on the other, or some pneumatic ducting and stick it on the other one. That to the least amount possible. Did I lose anybody there? Oh man, the big giant list. I'm having a hard time because it's actually on the next slide too. I'm actually having a hard time trying to figure out how do I ask this. So here would be the question: 1, 2, 3, 4, 5, 6, 7, 8. How many are on the next one? Oh, don't worry, I'll come back to this slide in a second. 8, 9, 10, 11, 12, 13. Name 14 of the 13 different things that you might have to disconnect. I don't like that idea. No, don't get me wrong. I'm just making a joke here. I'm just letting you know haven't figured out a good sample question to do this. Now here's part of the problem. I've done engine changes. How many people in here have done turbine engine changes before today? You have? You have turbine engine changes. How many? 1. Okay, sweet. Woohoo! So I've done enough of them that I can just sit here with my eyes closed and think about, okay, what do I have to connect and disconnect? Well, let's see, there's going to be fuel lines so the engine can run. There's going to be pneumatic lines off a jet engine pretty much always. There's going to be a multitude of electrical connections. Well, electrical connections, I got to have electrical connections for the starter if it's a smaller engine. Connections to an electrical generator. I'm going to have electrical connections to control the engine. I'm going to have electrical connections for the instrumentation, gas temperature, stuff like that. What other aircraft? That's at least 4 just on electrical. Let's see. I have to be able to operate the engine from the cockpit, so I could have mechanical controls that need to be hooked up. Did I already say pneumatics? Okay, I already said pneumatics. See, I'm just trying to figure out how many of these I could try to remember myself. What other things do you have to? Oh, very good. Hydraulic. Darn, I got that one wrong. Figure something out here. Ask me again. How are we going to memorize that 14 out of the 13 things you might have to disconnect? And then I'll get all irritated and say, fine, quit asking me. It'll be 15 out of 13. I could. I will consider that option. So you ought to have all of these things written down on your list, and then you ought to have all of these things written down on your list. Wow, look, there was another electrical, technically grounding and bonding. Oh, and there's a fire detection electrical. Holy mackerel. So that's like 6 different electrical things that you could connect or disconnect based on our list. Anyway. Oh, yeah. I haven't got to it yet, but I reviewed 500 power plant written tests that ASA, it's a company that prints cram courses for the AMT written tests. And you could select all power plant, or you could select just turbine questions. There's 500 of them. So, and because I haven't reviewed all the lectures for the rest of the semester, but we're going to be talking about how to operate a jet engine, which is really fun. Anybody ever operate a jet engine? Man, I love converting jet fuel into noise. It is fun. But talk about the law of conservation of energy. You take chemical energy, fuel, and you turn it into noise. And you stand near the back, and it smells like burning jet fuel. Yeah, hot dog, and stick it in the exhaust. Now, don't eat that hot dog. It's got a lot of chemicals in it that are bad for you. So I'm kidding about it. Unless you sealed it up in a metal container. Which, Yeah, no, wrap it in tinfoil is not sealed. You're still going to get the gases and particulates in there. Just think about eating. Sit down behind a diesel truck that's running and sit there and eat in the exhaust. Yeah, I don't think this is going to be good for you. So no, I've never actually cooked anything that I ate in a jet engine exhaust. Although I think maybe dipping popcorn would be pretty fun. But the problem is it's designed to heat from the bottom and the jet, so we need to mount the jet engine. Never mind, I'm digressing. Okay, so there, 13 different things. Wow, hazards. I should have left this up here and let people try to figure them out. 1, 2. I moved this one, so I'm telling you up front. This one we had on a different list. We had this on the list of things that you need to disconnect when you're doing a turbine engine R&R. So I moved it to hazards because it's hazardous to the aircraft if you don't put plugs and covers and caps on pneumatic lines, hydraulic lines, fuel lines, stuff like that. Question, Daniel. Skydrol poisoning. It's one of my least favorite types of poisoning because you don't get euphoric or anything off of it while you're dying. Because if you did, then maybe it wouldn't be so bad. Skydrol is a type of a hydraulic fluid, and it's generally run on airliners and big business jets, and it weighs less than regular 5606, 50 or 100 years old. I mean, they have slightly better versions of it, but it's not petroleum products. It's synthetic. The problem is it's poisonous. Now, it's not like if you drink a teaspoon, you're going to die today. But if you drank a teaspoon, you would be in the hospital, and they would pump your stomach. And depending on I don't know how bad it is. I know if you get it on your skin turns red, and it feels like you're having an extremely bad sunburn. And if you inhale it, I don't even know how bad if you were inhaling Skydrol fumes. I don't even know. Yeah. So Skydrol is a type of hydraulic fluid. It's found in airliners and big business jets, and it's really toxic to human beings. So when you're working on it, you're going to wear splash goggles, the kind that seal around your. You're going to wear big honking gloves and probably a plastic or apron. But hey, that's just me. Well, when you say we, you mean the airlines? Yeah. Airlines started using this stuff. Gosh, it was probably in the 60s or 70s. Fortunately for me, the only aircraft I've worked on that hydraulic systems were small enough or old enough, they used 5606. It's not that you can drink it, but it's not any worse than getting engine oil on you. I never leave the oil on my hands long enough for my hands to get sticky. So, hazards of removing and replacing jet engines, including this one that it was not on your list, so I'm sure you're going to add this one to your list and move it off of the other list. Fuel spilling, that's a hazard to everybody else, and the aircraft fuel on you, jet fuel, is not as bad for you as Skydrol, but it will become irritating, and it's really bad if you get it in your eyes. If improper connection to the hoist, so you're lifting the engine up, and you don't connect it to the crane or the hoist very carefully, and it falls off, that's a bad thing. Damaging the aircraft during removal, that means if you're taking the engine out or putting it back in, are you banging up the rest of the aircraft? Improper installation of the engine onto the stand. The engine has to go onto a stand so you can push the engine away from the aircraft. You got to put the bolts in correctly. So there's a place you could screw up. Securing the aircraft and moving, that would probably be something you'd want to do right away. Even if it's in a hangar, why do you want to make sure the aircraft can't move? Because somebody is going to open the hangar doors and make the airplane move. Electrically ground the aircraft so you can't get static electrical discharges. We already talked about Skydrol poisoning and preventing line contamination by using caps. Anybody have any questions? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, what are the 10 different ways out of the 9 listed hazards? I wouldn't do that. Is there? Don't tempt me to have fun, Elizabeth. Do not put temptation out there directly in front of me by saying that would make you very upset. Thanks for letting me know. Just so you know, I'm just kidding. All right, so and I can't spell from. From is actually spelled F-R-O-M. Obviously, the spell checker didn't catch me. Not form, from. So when the engine is out of the aircraft, yeah, we actually saw a gentleman doing that in one of those one of those videos we saw of an engine change in a hangar. You're looking in particular at the engine mounts, the airframe structure, any mechanical connections, any electrical connections, and any fluid lines. So this is pretty much everything that you're connecting or disconnecting. It's very basic, though. I mean, I didn't break out how many 17 different electrical connections. So anybody got any questions on that one? We've covered all that. That's all they were. We did talk about this the last day or two. It's like, what are these fluid lines that have fluid in them? And I'm going to say that pneumatic power has air in it, and we're going to call it a fluid for purposes of this sample question. So there's 4 different types of fluids, including air, that you could have going into or out of an engine compartment. Fuel, hydraulic, pneumatic, and engine oil. Although the engine oil is not going to go into and out of the compartment, you're still going to need to be looking for leaks. So that's mainly the reason why there's this list here is, what 4 types of leaks? So there's actually 2 ways I could ask this question. I could ask it at the top, what kind of fluid lines are going to be connected or disconnected? And then another one would be, what are the 4 major kinds of fluids you would have to look for when you're looking for leaks after you put the engine back together and you want to make sure nothing's leaking? What kind of leaks are you going to look for? I forgot to ask at the beginning of the hour, is it okay that I spend this 50 minutes today doing this? Because I could just go into the chapter 10. I know you might be disappointed because you read the first 10 pages out of chapter 10 last night and you were all fired up, and here you come to class and it's not chapter 10. Is anybody having that issue? It's okay if you raise your hand. It's not that many students will kick you. Well, just the ones that are within reach. Okay, sorry. R&R is an abbreviation for what 3 words? I know this is going to be tough. It's 3 words. Remove and replace. I actually use R&R in logbook entries because it's that standardized of an abbreviation that everybody reading a logbook knows what R&R is. So here's another question to add to this one. Remove and replace. What does that word replace here mean? Does it mean that I took it out, I fixed it, and I put the same one back in? I put a different one, now hopefully identical, but I put a different one in there. If you write R and R, that means a different thing got put back in the airplane. Removed, repaired, and reinstalled is a whole different thing. No, I've never seen anybody do R and R and R. No. Thank you for asking, but I've never seen that. Usually what I do on a log entry, I'll write removed spark plugs. Because I'm not going to just write R and R spark plugs, because I want to make out the fact that I did something to them. And I'm also putting the old ones back in. So I'd say remove spark plugs. Sometimes I'll just skip that because it's rather obvious that you removed them. If you cleaned them and gapped them and tested them and then reinstalled them, there's kind of implied. But I'll usually write in remove spark plugs, clean, gapped, inspected, tested, reinstalled, and reinstalled. Huh? I have a little thing that hooks. That's got some sand in it, and it hooks up to an 100 psi air. Just a little. It's like the gizmo we got over there on the wall in lab, except it's small and it's not as effective. It takes longer. Yeah, it's cheap. It's like $40. But I can do it out at the airport with a compressor. And I do the annual inspection of my airplane frequently. Well, I do it once a year, but I fly so little, I almost never get 50 hours. So the spark plugs are never that dirty. Where'd I go to? A place called Aircraft Spruce Specialty. You type in Aircraft Spruce on the internet, and they'll sell you lots of stuff. But there's more than what you can get that sort of thing at Aviall, and there's probably 10 other places you could buy that. At least 10 other places. So you wrote down that other question in there. What does remove and replace mean? It means I installed something that wasn't originally there, or I did not reinstall the old part. So I added this one. I added this one right here. So if you go find this list, make sure you put this one in here, because I was putting this slideshow together, and I realized that I forgot to cover this one. I had meant to, and I forgot. That isn't the only mistake I made yesterday, but that's a long story. So what do you have to do after you've got the engine installed? This is kind of also, what are you doing during installation, because there's one of them in there. Let's see. We're going to make sure we've done all the maintenance manual steps. Oh, there's a whole other question I didn't write down, but you can write it down now. Is what's arguably the most important thing you're going to do when you're removing and replacing a turbine engine? If you had to list just one thing, what about the maintenance manual? Have it in your toolbox, locked away inside of a Ziploc bag. Is that what you mean by have it? Have it inside. Okay, I pulled it out and I can see it through the Ziploc bag. It's inside, over there. I can see it. I know you're going to get there, Daniel. Or I'm going to sit on my other foot. Open it. Open it. Yeah, to the page that you glued in your own pages of politically incorrect pictures. Oh, wait, sorry, that's just me. What you would open it and look at what? Yeah, how to disassemble. Yeah, let me ask you this question. Would you actually use the maintenance manual to tell you what to do to take the engine out? Or would you just use what's in your head? Oh, okay, you'd use it to help you. Okay. How about when you're putting another engine back in? Would you follow the maintenance manual? It depends. So I don't like this engine, so I'm not going to use the maintenance manual, because I don't like the people that own this airplane. Well, it is very unlikely that you're going to take one engine out of an airplane and a different model. There are some supplemental type certificates where you can install different engines in the same airplane. But generally speaking, 99.99% of the time, if you take an engine out, you're going to put in a different one. You're going to put one in that's the exact same make and model. So my point here is, if I asked you this question, I tell you what, this will be like the first question on the test. What's the most important thing that you need to remember when you're removing and replacing turbine engines? Always follow the manufacturer's maintenance manual. Not have it, sorry, I got to harass you a little bit. It's fun. You're sitting in the front row with your hood on. So, but it's cold in here. Is off some air maintenance records, and you're going to say effectively, I swear, I promise that I did it the way the maintenance manual says. All right, so you're going to make sure you follow the maintenance manual. You're going to use new hardware, gaskets, whatever is required by the maintenance manual. You're going to rig controls. I got a question or two about rigging a little later here. You're going to make sure that you put in safety wire, cotter pins, lock wire, lock washers, whatever it is you need. You're going to check for leaks. We talked about checking for leaks. You're going to perform an operational check. We're going to spend a day or two next week or the week after on how to do operational checks with jet engines or on jet engines. And then the one I forgot previous to today is you have to do a return to service. If you're not familiar with the phrase return to service, that means you signed off the maintenance records, literally with a signature, whether you did it by hand or an electronic signature. You have to do the paperwork that describes what you did and when you did it. And that's where you get to take responsibility for your work. And don't worry, if you did it wrong and something happens, they'll just come back, and the worst they can do is fine you, take away your certificate, and sue you. Of course, the FAA won't sue you, just the people who died, their relatives who are alive. They can sue you. Do you have a question, Elizabeth? The only reason you would go to prison very likely, I'm not a lawyer, but I did stay at a Holiday Inn Express last night. The only reason you'd likely go to prison is if you knowingly did it on purpose. If you knew that you were signing something off and you knew it wasn't done right, now you could be charged with negligent homicide. And that is a crime, not just a civil penalty. But if you want to talk about getting sued, see me after class. I have a lot of experience. I mean suing other people. I didn't mean getting sued. Yeah, that's what I meant. Yeah, that's what I meant. So in 17 sentences or less, can anybody describe what is rigging? 13 sentences, or how about 2 sentences or less? Do I have a hand raised over there? No. Everybody's going to get this one wrong? Okay, Frederick, give it a try. You would get 100% credit for that answer. You said all the things I wanted you to say. It's your adjusting. And the controls could be mechanical, they could be electrical, which I'm not as concerned about. But it's this relationship between the controls inside the cockpit to what's going on at the engine. That's the important part. It's adjusting or changing or making sure that when things get moved in the cockpit, they get moved in the engine compartment the way they're supposed to. So that would be the 2 parts. Thank you. That would be the 2 parts to that answer. If I said, tell me, explain the basics. What happens, or let me rephrase that. What is the purpose of engine rigging? You would say adjusting the engine controls so that when the controls are moved in the cockpit, the controls in the engine compartment move correctly. Am I answering your question? Okay. Whoops, I missed a question there. We went over this one yesterday. Does anybody know? What are the 3 times generally when you have to rig engine controls? The remove or disturb. The engine gets moved, yeah. The propeller governor gets fiddled with. Well, somebody said the engine, if you disconnect the engine and wiggle it and then move the engine back into place. But what's on the engine that most of the controls go to? They go to the... It's bolted onto the side. It's bolted onto the side of the engine, usually on the side or the bottom. The fuel control. Yeah. Remember, that's similar to a carburetor or a fuel injection system. I know you haven't had it this semester. The fuel control is that the throttle, those levers in the cockpit, some or most of them go to the fuel control unit, and the pilot is saying, I want more power, I want less power. So if that part gets bolted or taken off of the engine and put back on, or a different one gets put back on, you have to rig. So if the engine gets disconnected, if the propeller governor gets disconnected, or if the fuel control gets disconnected, in any of those situations, you're going to have to do some rigging. I have an answer. It's answer C. Do you have another question?
All the test steps for do you accept abbreviations?
If you said FCU, yes. Because if I didn't know what it was, you could point to it in a book very easily, and you wouldn't have to say that you made it up.
Unless I did.
And then, unless you did make it up, and then I wouldn't accept it. Question? If you list 3 out of the 4, then you'd get that. However many points that question would be worth, you get 1/4 of it off. You'd absolutely get. Yeah, you'd get 75% correct. Yeah, you definitely would. I'm a firm believer in partial credit. Am I that type of a person? All right, I'm glad you're asking that question. Yeah, partial credit. You know, I do have an ink pen with multiple refills. Previous I've always, whenever somebody gets hurt in lab, people don't notice. I always clean it up, and then I rinse out and get the blood out of it and mix it up in the ink. So I actually have student blood in my red ink that I grade tests with. It just makes me feel better. Don't worry, I sterilize everything with alcohol. There's no fear of no risk rather of what is it? There's a phrase I'm looking for. Getting other people's germs. There we go. We already covered this question. If you don't know the answer, raise your hand and we'll laugh at you. I'm just kidding. We won't laugh at you. Nobody's raising their hand. That means everybody knows the answer. Wow. Whether it's a turbine engine or an APU, what's the red line? It's typically really, really close to, man, 100%. So what's the purpose of a pneumatic power system? What about, I've already harassed you enough, and you too, Friedrich, somebody else. Is it Friedrich? It's Friedrich, okay. I was looking at the spelling. Darf ich meine Bleistift spitzen? If I speak German, I can say Friedrich. Oh, Dankeschön, Friedrich. Can you sing O Tannenbaum? It's okay if you can't sing O Tannenbaum. You don't know. Oh, sorry. It's a German Christmas song. I think there's an English version. I wasn't singing a Christmas song because it was coming up on Christmas. I was singing a Christmas song because that's the only German song I know. Oh, wait, there's another one, but it involves dirty words, so I can't sing it. See me after class when we're on break outside of the building, and then I'll sing it. All right, let's get back on task here. So, other than those two gentlemen, or if you've answered a question, somebody in here somewhere has not answered a question. Know why you've answered a question. I just haven't called on you. It's your hat. I don't like your hat. Don't feel bad. Don't take it personally. How many people are going to get this correct on the test? Oh, you've given me an answer today. Surely there's somebody out there that hasn't given me an answer that knows this answer. And that's where you raise your hand and say, Mr. Johnson, I haven't given you an answer today, and please stop calling me Shirley. Okay, one shot. No, it's cheesy. It's a cheesy joke. Knows the answer and hasn't yet answered a question today is willing to raise their hand. Go ahead. For the second one, can I take you for the second one? I'll tell you what. Second question, what are the three ways? Pressure, volume, and heat. Pneumatic power can be used in three: volume and heat. Pneumatic power can be used in three ways. It's hot, because there's a large volume. Like if you go to the engine and to the leading, using it because air off of the APU and pumping starter high pressure, really high volume. What is the purpose of a pneumatic power system? What is the purpose of any power system? Is that easier? What? Transfer power from one place on the aircraft to the other. So what's the purpose of a pneumatic power system? That keyword. Transfer. The whole point of any power system, including a pneumatic power system, is to transfer power from one part of the aircraft to another. We're going to take power off of the engine in the engine compartment, and we're going to, via bleed air ducts or pneumatic ducts, we're going to take that power and send it somewhere else. See, here's your question, Elizabeth. Does anybody know all 7? How many do you have on your list right now? Surely someone has a list with hazards. That's not the correct. The correct response is not, quote, no one here is named Shirley. The correct response is, Mr. Johnson, there are only how many things on your list? 6. And then you would also say, and please stop calling me Shirley. Okay, all right. Well, that would be the 7th and correct answer. Yeah, you only have 6 items. It's because I came up with another one while I was putting this together. 5 out of 4 people are bad at math. Yes. So I want you to... F-I-R-E. Well, fuel spills can turn into fires. And fuel spills of themselves are toxic for humans. So even if it didn't catch on fire, we can't just leave the fuel sitting there. Well, normally, I'll be right with you, normally fuel doesn't spill during engine operation. But of all the times the engine is most likely to catch on fire, one of those top 2 or 3 times is after you've just put everything together. Because that's the most likely time you're going to have a fuel leak. Because the most likely time is because of human error. Question? This is engine running. This is engine operation. So if you, I think I did have the word on turbine engine running, and that's okay. How about if on the test I put run in parentheses or something like that, so it'll be a little easier. You're going to go out and you're going to fire up a jet engine on the ground and go woohoo. All engines added together. So one of the hazards is getting hit in the head with a propeller. So that's one hazard is the propeller hazard. Another hazard is fire. Somebody said fuel spills. Getting sucked into the intake. I hate getting sucked into the. Has anybody ever been sucked into an intake? I got to. Better if I don't ask any more questions surrounding that statement. Does anybody have any other questions about what's on that now list of 6, list of 7? How many are there now, Kenneth? There's 7? Okay, sweet. So now I have to change that question to be name 8 of the 7 different hazards associated with running jet engines. Don't worry, I'm not done. So I took those 500 turbine questions, and I looked through them. This didn't print out correctly, so it doesn't. The numbers are incorrect, but it's 1, 2, 3. I don't know. There's like 10 pieces of paper, and it's printed on both sides of the possible questions that I might get asked. But like I said, I haven't looked at all of the material that we're going to cover, so probably a third or a half of these questions aren't even applicable. But I did look through the questions, the FAA questions, that I thought would be applicable to what we've already covered. So here's a fun question. What must be done after the fuel control unit, FCU, has been replaced on an aircraft gas turbine engine? So now, so here's a good question. What is the FAA's term for rigging? Adjusting. Now, generally speaking, when you say rigging, you're talking about changing the way the controls are all hooked up. But especially in the old days, they used to do things to jet engines to make them perform differently. Like they would literally put obstructions in the turbine exhaust to make the duct smaller, to make the velocity go higher. Trimming. So I highly recommend that when you read the FAA questions, and when you find those questions that has the word trim in it, you read it. So trimming, as far as I'm concerned, that's encompassed in all of those adjustments you have to do after you put the engine together and before you sign the logbook. Trimming the engine puts out the right power or the right thrust. Yes? That's very close. That's very, very close. I would have said it that trimming is a little finer, final adjustment to what you've already done. I'll tell you what, it's 10 minutes up. So we'll look for the first 5 minutes tomorrow. And we're going to hit chapter 10. Class is dismissed. No, that's a metaphorical hit.